is Andrea Cimino, and today I will be presenting Astrea, which is an online tool to automatically generate SHACL shapes for a given set of ontologies. In order to use Astrea, the first thing we need to do is to access its main page. To do so, we need to type the link astrea.linkdata.s. We will be navigating to this main page, in which you can find here a short description of the tool and here a playground in which you can paste different URLs belonging to the ontologies. You can add more by clicking this button and then clicking generate shapes to generate the different shapes of those links. In the portal we have also another section called documentation. In the documentation you have these different sections which can be divided into mainly the description of the resources here, which are public available, and the conceptual explanation of the concepts of Astrea. In this case, you can have here the ontology of the mappings, the different description of the mappings, and the mappings list that Astrea uses to generate the shapes. By just clicking any of these tabs, we will automatically be redirected to that section of the documentation. Another interesting section of Astrea is this catalog of already built-in SHACL shapes. In this case, we have included different well-known ontologies, such as the one of DBpedia or the W3C time, or different Etsy Saref modules and others. And by clicking in these links, you will access the ontology, and clicking the shapes link here, you will be able to download their SHACL shapes. Also, on the tab menu here, you have the GitHub link, which will redirect you to our GitHub page, where we have all the technical documentation. And finally, the most interesting part for this demo is this tab, API REST. So we documented the API using Swagger, which offers us a playground, so users can actually consume the API REST through a graphical interface, as I will show you now, but also other services can invoke this API using the REST. So as you can see here, we have two main APIs, one for the generation and another one for the validation. If we click on the generation, we will see here that we have two endpoints that are expecting a post and both generate these SHACL shapes for the ontologies, but this one will expect to receive a document, and this one the URL of the ontology. If we click on the first one, you will see here an example payload you need to send through this post request. And if you click on the try it out, you will be able to modify the content or even change it for the one that you want to use to test Astrea. If by clicking on execute, you will see here that the node shape is generated. So analyzing this payload, you will see here that we are sending an excerpt of an ontology in Turtle, and we are specifying here the serialization. And here we are obtaining the related node shape of the excerpt of the ontology we sent. Similarly, we have here the endpoint for the URL. In this case, I click again on try it out, and for the sake of this demo, I will erase some of the URLs just to make it fast. And when I click here in execute again, Astrea will compute the SHACL shapes and return them here, as you can see. Now, if you focus on the SHACL shapes generated, most of them are restrictions for the data model. However, as you can see in this example, by using the XSD type, the data types of the literal, Astrea is also injecting some restriction regarding the data value. And finally, in the validation endpoint here is also a post. I will click again and try it out. We can specify coverage, which is a parameter I will explain now. We can specify here the data we want to submit, and very important, the format, and here the shape we want to use to validate the data, and again here the format. As you can notice, the formats can be different. Now, going back to this coverage field, This is a parameter we have specified. I will click here to show it to you. In order to have in the report this line here, which basically is specifying which types are covered by the SHACL shape. This is very important because when you have an RDF document with types that are not covered in the SHACL shape, the shape will validate as true. So it is important to know that even if the data conforms to the shape, it's relevant to know that the types specified in the shape are actually the ones sent in the RDF. And this is the goal of this parameter here, coverage. And as you can see here, it will include here the coverage and the type. If we specify false and we again execute, you will see that now we don't have such result. This is all, so thank you very much for listening, and if you have any question, please send us an email. Thank you.